Hi folks, welcome back. In this video I will explain the further part of the project, that is making the model. It's actually a CNN model. Okay, so here in this code snippet we are just importing the necessary tools and the libraries. Okay, after that I have made the CNN architecture. Okay, so I will explain you with it with a figure actually. Here we can see first we have a input layer. Okay, then we have an embedding layer of this size. Okay, after that we have three convolutional 1D layer. Okay, actually after that we will concatenate all those three outputs, this and this, and the output of that concatenation will be 5271 cross 32. Okay, this dimensional output. It is built on the top of max pooling 1D layer actually. After that again we have three convolutional 1D layer. Again we are concatenating it. Okay, again it is on top of max pooling 1D layer, and after that we have a single convolutional 1D layer. Okay, after that we are flattening it with a flatten layer. Okay, then we apply a dropout layer with 0.5 dropout. Okay, then we have a dense layer whose output will be in 10 dimensional. After that we have output layer, which is also a dense layer, which will output 20 dimensional, in which we apply the softmax layer. Actually here we can see we apply the softmax activation function to give a single best label or class for it. Okay, after that we compile it. Okay, we used Adam optimizer, categorical cross entropy as the loss, and for the matrices we use accuracy and micro f1. So basically we have to use micro f1 for our model evaluation. Okay, so let's see how many parameters we have. We have total number of 6,079,000 parameters approx, and among them only 619,000 are trainable, and rest of them are non-trainable parameters. So what are the non-trainable? The parameters which are from the embedding layers, basically, because they are already trained. Okay, we are just importing those vectors, globe vectors. Okay, so we don't need to train those vectors. Okay, here we are going to fitting the model or training the model. Okay, so we will store our logs in logs1 folder. Okay, after that we have callback. We have used callback reduce on plateau. Okay, reduce LR on plateau, which is basically for reducing the learning rate by 10%. Okay, after every 10 epoch. Okay, then we have a class called loss history. In loss history we have two functions. The very first one is on train begin, which will be called on when the train begins. Okay, after that it will just create these variables, list of variables. Okay, after that on each epoch end this function will be called, and this will just append or update the variables. Okay, we are just creating the instance or object of the loss history class here. I think fancy. After that we have a model checkpoint. Okay, here we will save our best model. Okay, so the file path is in this. Okay, validation accuracy will be our monitoring criteria. Okay, we save only the best. That means whenever the next best will come, it will just delete the previous one, or you can say override the previous one. Okay, after that we are calling a callback, a TensorBoard callback, which is very useful. We will see further. Then we have a earliest stopping. It is a very useful criteria. When earliest stopping callback is very useful callback to not overfit our model. So whenever within 5 epochs, when our model is not doing good on validation accuracy, then we will stop it, so that it can't be overfit. Okay, after that we in callback list we just arranging all the list of callbacks in a single list. Okay, after that we are training it. Okay, with the train padded and train class x and y. Epochs is equal to 100, validation data is equal to this, test pattern test class, batch size is equal to 16, callbacks is equal to callback list. Okay, so I won't bother you in these numbers. Okay, instead of that I will show you the graphs. So yeah, we can see here the epoch accuracy graph, epoch versus accuracy graph. The I want to tell you first of all, the blue one is here the validation, and the red one is here the training. Okay, so here we can see that we excuse me, here we can see that at the last epoch, that is 21th epoch, you can see here written 20 because it's starting from 0. Okay, so 0 is considered as 1, so 20 is considered as 21. So at the last epoch we have got 69 as the validation, and at the training we get 92%. Okay, we can also see here. Okay, here you can see here accuracy is 93 and validation accuracy is 69. Okay, yeah. Okay, after that we have epoch versus f1 score. So how did it perform? Okay, at the last epoch we got 61% for the validation. That was our evaluation criteria, and we have fulfilled it because it was minimum, it should be minimum 60%, but we have achieved 61.3%. that's very good. And for the training it's 90%. Actually we can see that there is a huge difference between training and validation, so it's actually kind of overfitting. Actually the model actually shouldn't be like that, but it's okay. Let's see what we can do to improve these models. Okay, after that let's see epoch no. Yeah, epoch versus loss. How does the loss okay, no, yeah, accuracy, why isn't showing? I not show. Oh, because it's disconnected. Okay, it's okay. Let's see how our loss did on our training and testing side at last. So it was 20%, 20 the loss was 0.2. Okay, and the validation loss was 1.89. There is a huge difference between these numbers, so it is kind of, we can say that our model has been overfitted actually, so we shouldn't do like that. Okay, let's move forward. This was our for the word embedding. Now moving towards the character embedding actually. Okay, so character embedding, in character embedding we have we will explain it in the next video actually. Okay, these are the things that we will use. Okay, thank you.